In this video we'll show you how we can produce a roughing pass for the IGES file that's been imported. So this is the file here. So the first thing we need to do, looking at the triad in the bottom left hand corner here, is set up our 0 position. So to do that we go into milling, set origin, so this is the date and position for machining, and we'll set it to the minimum in X and Y and the maximum in Z. So that moves the model down such that the top of the model is at Z0. So all the machining that we do in 3D CAM is based on sketches and surfaces. So the first thing to do is to create a sketch, and what we want is we want a sketch which represents the boundary of the cavity there. So to do that we right click the mouse and say pick faces. As we move the cursor across the model it highlights just the faces. So we'll have that top face and we right click the mouse and say make a sketch from the face. So what that does is, over in the objects window here, it has an extra entry now which is called sketch 1, which is a combination of the inner and outer boundaries of that face. So we want to split that sketch. So to do that we right click the mouse and say split sketch, and now we've got two sketches, one for the outer and one for the inner. So it's the inner one that we're interested in. So we need to create a surface so that the machining can be projected onto that surface. So to do that, under the milling ribbon we choose surface, and because this is a roughing pass we're going to leave a material allowance of 0.5 millimeter on that surface, so that we've got some material left to use for a finishing strategy. Okay, so that's going to create a surface for us that we can use to project the machining onto. So let's have a look at the tools we've got. So if we hit the plus button next to tools, it shows us the tools that we've got. If we need to, we can define more tools and save them away in a tool library using the new tool button. But if we highlight a 10mm end mill, that looks about the right size to machine that cavity. So what we'll do then is we'll produce a machining path based on sketch number 3. So to do that we highlight the sketch, right click and say that we want a pocketing operation. So what this does, when we open the pocketing or the profile operations, it remembers all the parameters and values that we entered on a previous job. So let's set the step over to say 5mm and the material allowance will be 0. The starting place can be at the boundary or it can be at the center. So if we work out from the center or the boundary, we'll start boundary this time. We can either climb or conventional mill. So normally you'd want to climb mill, and we can either use zigzag style or we can use contour style. So we'll use zigzag style for the roughing, and we'll choose the tool that we're going to use, which will be a 10mm end mill, and we'll use the surface that we created such that the toolpath is projected onto that surface. The clearance plane is a position above Z0 where it's safe to rapid. The feed change plane is a position above Z0 where the tool changes from a rapid into a feed rate. The work surface, which is the top of the job, would normally be Z0, and the final depth is however deep you want to cut it. But don't forget that this is going to be projected down onto the surface, so it'll only cut as deep as the surface allows us. So the step down we'll leave at 0 for the moment, so we can just check that it's creating the right toolpath for us. When we're happy that it's got the right toolpath, then we can come back and we can reset some of these parameters. The feed rate that we want to use is the horizontal feed rate, vertical feed rate, and the spindle speed is set here. So we click OK, and that creates that toolpath that you can see on the top of the model there. Okay, so we know that it's doing pretty much what we expect it to do, so now we can go back into that pocketing command and we can set the step over to something smaller, Now obviously this will all depend on the material that you're cutting and the tool that you're also using. And we'll set the step down as 2.5 millimeters as well. So that goes away and recalculates that job. Okay, so that's produced the roughing toolpath on there. Now one thing that we should bear in mind is that when it's creating the toolpath, the tool will be kept inside the sketch that we've created. So if we want the tool to extend past the sketch by the tool radius, then we can set that under the pocket option here, and we can say material allowance. So a plus value will leave material on and make the toolpath smaller than the sketch. If we use a minus value of the tool radius, then it will increase the size of the sketch and recalculate the pocket so that the center line of the tool is in contact with the edge of the sketch. Okay, so that's created that toolpath, and if we wanted to simulate that, firstly we need to save this file away. So I'll call that CAD1R, and now we can simulate that. So that's creating the data for the simulator, and then when it calls up the simulator, it creates a piece of stock material as a default, which is just slightly larger than the toolpath. We can set up our own stock values if we like, by going into the stock tab here and saying define the sizes, but in this case we'll build the stock from the extents. So this is now calling up the machine tool simulator. So when we run this, I'm in workpiece focus. We could also be in machine focus, but normally workpiece focus is okay. And then we've got the simple video controls across the top here. This slider sets the tool speed, and this is the run button. So we can see the effect that the machining is having on that shape, where the tool is only able to get in to where the surface allows it to machine. Okay, so we can close down the simulator, and then we're back to the job. So In this case we would then want to add on a roughing toolpath, a finishing toolpath, and we'll cover that in a subsequent video.